Right. Okay.
Perfect. Thank you.
Okay, there you go. The recording is in progress. So when you start off with our lesson, let me just, for the recording, do this. You go to collaborative notes on our website, you open up the Etherpad, and on the Etherpad, we're going to interact today on the Etherpad. But before we can start with the lesson, I would like you to click on this link, the Python Novice Information Setup.html, and it will open this page. Okay, I see my, can you still see my screen? I hope so.
Yes, we can still see it.
Okay, great. Okay, so when you get to this, you'll see that the heading is programming with Python setup, and install Python. They want you to install Anaconda. The reason for that is Anaconda has got a lot of extra things in it in the Anaconda Navigator, but we'll get to that in just a moment. And what I would like you all to do now is please click on download the Python Novice Information Data.zip and the Python Novice Information Data Information Code.zip. Okay, so that will throw it into your downloads. On Windows, it will be under downloads. On Mac, it will be under downloads. On Linux, it will most probably be under your downloads in your browser, depending on which flavor of Linux you have. Okay, and then as soon as you unpack it, I'm just going to open my Finder here. On the downloads, you will see it will be under downloads there. What I did was I just unzipped it to my desktop, and then I threw it in a folder or directory, depending on where you are in the world. And then I wrote code and data. So when you unzip it, let me just show you. If I unzip this, you can simply double click on it, it will unzip, and then you will see it's either written data or code. So copy and paste that onto your desktop, and then please make a folder and throw it in there. You can call the folder whatever you'd like to. I just called it Software Carpentry 428 April, but you can call it data, you can call it Python, you can call it whatever you'd like to. The thing that we want to focus on is the data part. The code, I'll talk about that, I think, a little bit later, but for today we want to talk about the data. When you open the data folder, you'll see there's a lot of different CSVs, and there's one untitled IPython, that's mine, so don't worry about if you don't have this. Just make sure you have all the information and the three small 01, 02, 03.csv. Okay, so why I want to say show of reaction. Do any of you not have the data yet, or are you struggling to download the data? Because from here we're going to start working with the data itself, and I'm going to move over to the Anaconda Navigator so that we can start with the lesson. Okay, so if any of you have issues, please let me know. I see there's 2 unmuted people, or do you have issues?
Martin, good morning.
Yes.
My name is Dr. Shrikant. I have already installed Anaconda Navigator in my computer.
Yes.
Can I use the same version for this training? Is it okay?
Yeah, no problem.
No problem.
When I installed it yesterday, I just made sure everything was fine, and then when I opened my Anaconda, it also told me there's a newer version, but it's not necessary.
Okay.
You can just use the version you have. It's not like R, for instance, where you have to keep up with the specific versions, because there are libraries that don't work within Python. As long as you have Python 3, then not 2.7, then you shouldn't have an issue.
Yeah. I think I will use the Spider IDE for executing these programs, the Python programs. Can I use it in IDE? In IDE?
Yes, you can use it as well.
Yeah. Okay.
As long as you can execute it.
Yes. Yeah, I can do it. I think in the Anaconda Navigator, I have already installed the Spider IDE for Python. So it works same like the Python 3 and above version. Okay. So I can use it. Yeah.
The nice thing about Python is you can use it in pretty much any environment. Yes. You can use a vanilla Python, you can use a terminal, you can use any IDE that you like to use. You can also use Jupyter Notebooks. it depends on your personal preference.
Okay, right. Thank you. Thank you, Martin.
Okay, no problem.
Thank you, Martin.
No problem. Okay, Crystal, do you have any issues?
Yes, I'm still setting up my, because I didn't take the space, I got the space now, yeah. Okay, now I think.
Christelle, are you okay? Shame, I thought you coming to my house. Hmm?
Yes, I'm okay now, I got the space right now.
Where? At physics department?
Okay, yeah.
Are you on campus, Christelle?
Yes, I'm on campus now.
Okay. Who must I ask for them to give you space to sit tomorrow and Friday? Huh? Or can you make a plan? Shame he's busy setting up. Okay. Martin, the same yesterday, Shame Christelle has got some challenges. So what I basically suggested is maybe continue. He will just watch, and then later on he can just on the recording, you know, try and catch up, even if he has to do the course again or somebody else helps him. So I think go ahead, that's fine. Thanks, Martin.
No problem.
Okay, cool.
Okay, so when you're done unzipping the data, putting it on your desktop or in your documents, wherever you can find it. If you know your system quite well, you can put it in documents or wherever you are comfortable with. I just put it on the desktop because I like a clean desktop, as you can see. So it's quite easy for me to just get to it when it's on the desktop. Okay, so getting to our lesson, we are doing a lesson programming with Python, the software carpentry programming with Python lesson. And the scenario is it's a miracle arthritis inflammation cure. So the imaginary colleague, Dr. Maverick, has invented a new miracle drug that promises to cure arthritis. And within only 3 weeks since you started taking the medication, and we're going to go through the clinical trial data, and we're going to see if we can work with this data within Python and what we get to verify this trial data. Okay, so our CSV file contains a number of inflammation flare-ups per day for 60 patients in the initial clinical trial, with the trial lasting 40 days. So we have 60 patients and over a 40-day period. Each row corresponds to a patient and each column corresponds to the day of the trial. So please remember that, because that's actually going to come into what we're going to talk about, and what we're going to work on is the columns and the rows. We're going to focus a lot on that. Okay, so once the patient has their first flare up, they take the medication and wait a few weeks for it to take effect and to reduce this flare up. So to see how effective the treatment is, we would like to calculate the average inflammation per day across all patients and plot the results to discuss and share with your colleagues. So this is how a clinical trial normally works, and this is how the research on this trial will work. We have our patient data, which is all anonymous. We're only working with the numbers, flare-ups and inflammation days, and then we're going to do an analysis on this and see if this miracle drug actually works. So we have the data now, and it's separated in, it's saved in a CSV, which is called a comma separated values. As you can see here in this little block called code, you will see that there are examples of our data, how they save the data. The reason we're working with the CSV, it's just a little bit simpler than working with a specific proprietary software's version. For instance, if you use a XLSX, which is Microsoft Excel, it might not work as well. So the CSV is sort of a universal delimiter which we can work with. Okay, so our prerequisites for this is you have to make sure that you follow the setup, which we just did now. Make sure you have some sort of Python. And for my instance, for what I'm going to do today, I'm going to use Anaconda Navigator to get to Jupyter Notebooks. The reason we're using Jupyter Notebooks is most of us are on different types of operating systems. As you can see, I'm using Apple Macintosh. Some people are using Windows. Some people are using different flavors of Linux. So Jupyter Notebooks runs in your navigator, in your browser, and then it means it's independent of what operating system you are working on. It works in your browser. So if you have a Firefox or a Google Chrome, Safari, it will work. Okay, so getting started, we're gonna start with our Python fundamentals. But before we get there, let me just show you our Anaconda Navigator. I hope you can still see my screen, or you can see Anaconda Navigator. So the reason that the Carpentries like this so much is when you install Anaconda, you will see that you already have Data Law, you have IBM Watson Studio Cloud, Jupyter Lab, Jupyter Notebooks, Qt Console, Spider, and you have the option for a few others. What's also nice about this is there's some documentation on most of these things. When you click on learning here on the right hand corner, on the right hand side, you'll see that there's some documentation on Python tutorials, Python reference, Anaconda package list, and the list goes on. There's a lot of information there. And there's also a community. So if you have any questions, you can go from here, you can navigate to Stack Overflow, for instance, you can go to Anaconda forum, even Matplotlib mailing lists and so on. So there's a lot of information here, there's a lot of support here, and all of this is for free. So that's the reason that we like Anaconda so much. So when you click on launch Jupyter Notebook, you will see that it launches it in your default environment, your default browser, which means that for me it is Firefox. Okay, so I'm using Firefox because it's easy to navigate and I like it more than most. And so Jupyter will open something like this. No, will look like this. When you click on home, you will see that when you open it, it is localhost with a colon 8888/3. And then you will see this. The 3 part is all your systems. So I don't know exactly how yours will look. Mine looks like this: applications, Creative Cloud, files, data carpentry, desktop, documents, downloads, movies, and so on. Yours will look much different from mine because every person's desktop, every person's computer is set up for their own use. What I would like you to go to is click on desktop. If you can find the desktop somewhere there in that tree, click on desktop once and then navigate to that folder or directory that you just created. Now I know some people will have full desktop, so you will have quite a long list here. Look for the folder that we just created this morning. When you click on that, it will then show you code and data. Okay, so if you're struggling to get there, please put up your hand so I can see who has issues, so we can make sure that everybody stays on the same page.
I'm with you, Martin. I got it. I have all
Okay.
the data and code with me. Yeah, I can browse through the Jupyter notebooks. I have launched the Jupyter, and I can browse through the desktop so that I found all my code and data in it. Yeah,
Okay.
it's there. Yeah.
Okay, so what I'm gonna do, I'm just gonna shift my lesson over to this side so I can actually follow it properly. Okay, so while I give you a minute or two to sort out your computers, yes. Michael, do you have any issues? Tsepo, I see your mic's unmuted. Okay, yeah, muted again. No problem. Okay, so I take it everybody sorted out. So when we look at our navigator, our setup page, we navigate a little bit down, you'll see launch the Python interface. What I would like you to do is go to Jupyter Notebook, launch it. As we just saw, you'll see different screen from mine. Then navigate to your information data. And what I would like you to do then is click on new. So when you look at your data here, there you will see in your Jupyter Notebook, you'll see all the information data, and just above your directory, you will see that there's a button called new. So when you click on new, it will give you a few options. So please click on Python 3 or IPy in brackets. When you click on Python 3, it will then open a blank notebook or new notebook that looks like this. Okay, it's still untitled, and you'll see it's last created a few seconds ago, and that's not an issue. We can rename it at some other point, at some other time. No problem. We just would like it to be here for now. Okay, so if you're not there yet, don't stress about it. Just take your time, get there, and then we'll take it from there. If you're struggling to get there, please put up a hand or a reaction so I can see, and then we can make sure to sort everybody out. Okay, I'm gonna stop share for a few seconds. I just need to shift you all guys over to my other screen because I need the bigger screen to put the Zoom session and all of that on, and the smaller screen to actually work on the notebook. So just bear with me for a second or two. I'm just going to stop my screen share for now, and then within half a minute or so, we'll be back online. Okay, I see quite a few people has joined us since we started. For those of you who just got into the room, welcome. We are recording the session, so you are more than welcome to ask Renee for the recording afterwards, or ask me to get the recording to you, and then we'll make sure to get you all on the recording. Okay, so as I'm navigating all my stuff and moving my stuff, do you guys have any questions? Do anybody have any questions for me at the moment?
Martin, is this
Yes.
Jupyter Notebooks works very similar to like an IDE, is an integrated development environment kind of thing, or is just to work only with Python it is useful?
I think the Jupyter Notebook is a little bit less intensive than an IDE. It's more for the, I want to say, the everyday user,
Okay.
the guy on the street, where IDE is more for specific purposes for programmers and so on. So I would say the IDE is a bit more advanced than the notebook.
Okay. So
Remember,
it's
the Carpentries lessons are aimed at complete novices. Now, I know not all of you are novices. Some of you are more advanced than me. So the lesson is set, the tone for the lesson is set that it is aimed at novices, people that have maybe opened Python once or twice, maybe used it once or twice in their life, but not an everyday user, for instance. So the whole idea around the carpentry lessons are to get you to a point where you understand Python a little bit better, and you can go back and teach yourself more skills. So I think the notebook is a bit less intense than the IDE.
Okay, then okay. Thank you, Martin.
Morning, Martin.
Morning.
Yes, those ones who maybe cannot find the notebooks, what can they use? Colab?
I'm not sure what the software is, but like I said this morning, you can use anything that you'd like to use, as long as you can follow the lesson.
Okay.
Okay, so when, I don't know if you were here in the start of our session, but we.
I'm on. I've just opened the notebook on my side.
Okay, no problem.
Yes.
Okay, so what I said was we're going to use the notebook because that's what the lesson material asks for, and it's a bit more, it's easier to use than most programs, and we're using it via Anaconda because Anaconda has a lot of resources that are free to use for everybody. Okay, so Obi, I see you have an issue with finding your desktop.
Can I just upload the files straight into Jupyter Notebook? The files in the data and code using the upload button in Jupyter.
Okay, you can do that as well, as long as you can get to it and use it, because we're gonna import it in a few minutes, because we're gonna work on the data. So you can upload it to Jupyter Notebooks, not a problem, as long as you can use the data.
Okay, all right.
Because the whole lesson is about using that specific data. So the first part, we're going to do Python fundamentals, then we're going to take a break. So if you haven't done it just now, don't stress about it. We're going to take a few minutes break before we start using the data. And we're also going to do some exercises. So you will have time to sort it out by then. And then we can see when we start with the second part of our lesson today, analyzing patient data. Then we're going to use the data. So if you're struggling by when we get to that point, just let me know, and then we can work on it. Okay, so everybody should see my screen now, my desktop one on my side. So you'll see my Jupyter Notebook with my untitled book. Don't worry about the untitled part. We'll get to that in a few minutes. Before we work with the data and make sure we don't lose the data, because I know when you come back tomorrow, sometimes you shut down your computer and we come back tomorrow, it's a little bit haywire. Okay, so what we're going to do now is we're going to start with the Python fundamentals. Now, the first part of this is variables. So any Python interpreter can be used as a calculator, for instance, and I really mean any Python interpreter, because they use the Python kernel. So for instance, if you do basic arithmetic, 3 + 5 × 4, for instance, and you run this, you see there's a little run button there. When you click on that run button, it will give you an output of 23. So you can use this as a normal calculator, but it does not mean anything, because now you've done the sum or the arithmetic and the output's 23, and now Python has forgotten about that because it's not saved anywhere. Now, that's where the variables come in. So a variable is something that we use to assign value to. So when you want to make sure that you save something, you have to assign it to a variable. Now, a variable can be called anything that you like to call it, but in Python's case, you cannot use, you cannot start with letters, for instance. Not letters, sorry. You cannot start with numbers, for instance. So you can use, for instance, weight 0, but you cannot use 0 weight. Okay, because 0 is a number and it's seen as arithmetic, and you cannot use that in the start of your variable name. So variable names should be something that makes sense to you as the programmer, and should be something that when you come back later, you should be able to see what it is. Now we're going to start with weight in kilograms. So weight _ kilograms. The reason we use underscore is it's not a specific assignment and it's not part of any Python language. So you can use the underscore and it will not be an issue if you use the underscore. Now the way that we assign a value to a variable is just one equal sign. Oh, yeah. Sorry, I'm typing in the chat. One equal sign, you will see that it is purple on my screen, or pinkish. And that means that you are assigning a value to this variable that you called weight. So we're going to say weight = 60. Now you'll see that I don't have a space between my kg and the equal sign. You can make a space there if you'd like to, or you can leave it against the last letter. It's not a problem. Python won't have an issue. Now I know it's sometimes tedious to click on run every time. So there is a shortcut as well. It is Shift and Enter. So if you want to run something, you press Shift and Enter at the same time on your keyboard, and it should run your script. Okay, you'll see that there's no output here. because we just saved it to somewhere. So there's no output given at the moment, but the value is saved to wait. Okay, so in Python, a few things to remember with variables is you cannot use numbers at the start of your variable name. You can use underscores, you can use uppercase, lowercase, but please remember that it is case sensitive, meaning that if you type wait with a capital W, it is not the same as wait with small caps. Okay, so it is case sensitive, and it's something to remember. Okay, so we get a few types of data in programming, in mathematics, in I think when you look at statistics and all that. So Python is no different from that. Python also has a few different sets of types of data, but the most common ones that people use is integer numbers, which is just a full number, which is maybe a 6 or 5 or 7 or 8. And then floating point numbers, which is then like we call it decimal numbers. So if you have a 6.7 or a 7.8 or anything with a point something at the back is called a float. And then strings. Now string is called it's when you use words in your variable, and to do that you normally use inverted commas. So let's work with some of this. So in our example here in line 2, that is an integer number. So we assign the integer number to weight, but that's not necessarily as accurate as you would like it to be. So most of you have seen when you step on a scale, you are maybe 80.2 kilograms or 60.1 kilograms or 88.9 kilograms. So let's assign this to the weight as well, so we can have a little more data in the weight. So let's say weight equals 60.3. Now you'll see that I don't have white spaces in this case. Still takes it. So the white space is just there for yourself to read it a little bit better and to make sure that you don't get confused. Okay, so what I always say is when you program, everybody's programming style is like your handwriting. Everybody's style is different. Everybody likes to program the way that they like to see. Some people use a lot of comments, some people don't use comments at all. It all depends on who you are. So for today, I'm going to try to stay as neutral as possible. I don't want to teach you any extra stuff that you don't necessarily need. Okay, so to create a string, now string is normally used to identify people or identify a specific data set. It's something that describes a specific piece of your data. So in our case, we're using patient data. So let's call it patient ID. And then we're going to start with the number 001. Now you can use single inverted commas or double inverted commas as long as you stay consistent, meaning that I can't do this and then think it's going to work. As you can see there, let me just make a space so you can see properly. Is my screen big enough? Can all of you see? Should I zoom in a little bit?
It's fine for me.
Perfectly fine in this side as well.
Okay. So when you do this, what I just did was make a double inverted comma and then a single one at the back. You're not consistent, meaning that the interpreter might not interpret it as you would like it to be interpreted. So either use 1 or 2, but please make sure that you stay consistent in the sense that if you use 2 in the front, you should use 2 in the back. If you use 1 in the front, you should use one in the back as well. And then we can run this. Meaning now we started in line 2 and we said weight is 60. Then we overwrote that variable and we said weight is 60.3 and we created a patient ID with 001. Okay, now you can do basic arithmetic on your variables as well. And remember, your variable has a value to it now. So meaning that 60.3 is equal to weight kg, or weight kg is actually equal to 60.3. So once you have this and once you've saved it, you can start doing arithmetic on it. You can start augmenting it and using it to create other variables as well. So what we would like to do is create a weight pounds, and we say it's equal to 2.2 times our weight in kilograms. Okay, so I'm going to see if this works. Yes. When you have a variable that is already saved, or you're busy writing a new variable, when you don't want to type everything, because I know I'm a lazy typer, when you have a certain part of your word or certain part of a variable, you can use tab. You know, like press on tab, you will see that there's a weight kg and a weight lb, and you can see which one you would like to use. So in my case, I would like to use weight kg, and you can see it is highlighted, and you just press enter. So it automatically gives it to you in that line. So when I run this now, I assign the value to weight pound or weight lb. LB is the shortcut for, or the acronym for pound. Okay, so we might decide to add a prefix to our patient data maybe, or assign a new value to our current variables. So let's augment this patient ID and give it a bit more description. So a patient ID, so I press tab, and there's only one patient ID or one variable with the name patient. So when you press tab, it automatically fills it up for you. And then we say is equal to, and let's call it inflam underscore, and then we add our patient ID. So as you can see, even though patient ID is a string, you can also do arithmetic on that as well. So I see I wrote inflam wrong. Inflam. So this gives a little bit more description on our patient data, because we're working with inflammatory patient data. So it means that the patient ID will then now be inflam underscore 001. So let's do this. Okay. If you hear the dogs, I do apologize. I have Jack Russells, and they like to bark at anything and everything. Okay, so built-in Python functions is something that you can just use. You don't have to go and recreate the wheel. It's already created for you, so you can just use it. For instance, print. Now, we've created all of these variables, but we have no idea what they saved it as. We take it for granted that it's saved as the way you'd like it to be saved. But when you augment a variable, you're not necessarily sure how it works or how it saved it. So to verify, we can use print. Now, print is one of those predefined built-in functions, and there are a few of them in Python. So I think, let me just show you a few of them. Okay, so in Python, you have, okay, sorry, that is the wrong one. Okay, there you go. All right, so in Python, you have a few keywords that you can use. So there's a glossary here for the lesson, and this glossary is a Carpentries page as well that shows you that within each lesson, I'll give you the link now in the chat as well. Within each lesson part of this Python, you'll see that there's a few different parts. There are some words and some functions that you can use without predefining them, and they are all highlighted here. So for instance, numpy, array.shape, print, and as you go down, you'll see there's a lot of them. So I'm going to give you this link as well in the chat. Okay, so it's in the chat for those of you who'd like it, and I'm also going to put it on the Etherpad as well. Okay, so getting back to the lesson, when we look at the print function, it literally just shows you on the page in human readable form what your variable is. So if we use weight in pounds, and we can also use patient ID. and we run that line, it should give you the values of your weight in pounds and your patient ID. Now, weight in pounds is totally independent of weight in kilograms. What do I mean by that? If I now go and I write weight in kilograms is a new value, then weight in pounds will stay the same, 132.66, except if I go and run that function again. What I mean by that is when we go to the structure of this, you will see that weight in kilograms and weight in pounds is independent of each other. The only reason that weight in pounds has the value that it has at the moment is because in line 5, we did that function. And we said that 2 times weight in kilograms. And that means weight in kilograms at that specific moment. So in that part of our lesson, or in this part of our script, it means that the weight in kilograms was 60.3, thus the weight in pounds is 132.6. Okay, so if you would like to print your patient ID and you want to see what your specific patient weighs, you can also do a print with different things in it called a nested function, meaning I can put my patient ID and I separate it by a comma and I write a little sentence here, sorry. Write a little sentence here, weight in kilograms, and then I call up my weight in kilograms. And if I run this, it will show you inflam 001 weight in kilograms is 60.3. Okay, so it means that you can put different variables within your print function, and you can also do a lot of stuff in your print function. So it's not just showing you what to do. You can also do some arithmetic on this function. Okay, so another function that we sometimes use and we would like to use is the type function. Now, this type function tells you what type of data is, what's the value of the data and what type of data it is. So when we look at this print function and we say we want the type of 60.3. So this will tell you exactly what the type is, but you can also then use a variable. So if we say print type of our patient ID and we run this, it will show you that 60.3 is a float or a decimal number and patient ID is a string. The reason that it sees it as a string is because of the inverted commas. So you can either use the specific value, or you can call up your variables and it will tell you what type of the data is. We can also do some arithmetic in your print function. So say we want to use the weight in pounds, but we don't have as you can see, if you don't use the inverted commas, some of your typings are functions that Python understands. As you can see, the weight in, for instance, is also a function that Python understands. So that's why it's always necessary to put the inverted commas if you want something to be printed as a string or a sentence. Okay, so weight in pounds is 2.2 times the weight in kilograms. So let's just make for now, just say we never did the weight in pounds function, and we want just to see the weight in kilograms. And then if we print that, it shows you weight in pounds, 132.66. So it means it's in pounds. So that's what you have. Okay, so as you can see, we never changed the weight in kilograms yet. So it still stays 132. So if we then go and we say we want our weight in kilograms to be equal to 65, and we print that, and we say weight in kilogram is now weight in kilograms, and we run that, you will see that weight in kilogram is now 65. So line 11, what it did was we reassigned a value to weight in kilograms, so it is now 65, and then we printed it to show us what the new value is. Okay, so our variable is now 65. Sorry about that, just had to clear my throat. Okay, so you've seen actually what the next part of the lesson describes is called variables as sticky note. So a variable in Python can also be seen as a sticky note. So it assigns a value to that specific variable. What it means is if I type in weight, for instance, it already gives you that part. It already shows you that it does exist. So it makes life a little bit easier for you. So what this analogy now, actually the sticky note analogy does. Now, I don't know if any of you have ever been in an in-person Carpentries workshop. Now, in-person Carpentries workshop, we normally hand out sticky notes so that people can tell us if they are still with us, or if they have questions, if they are still busy but they don't need any help, stuff like that. So in this case, if you see it as a sticky note, assigning a value to a variable is like putting a sticky note on that particular value. So using this analogy, we can investigate how assigning a value to one variable does not change the value of the others. That's actually what I've been talking about as we're going through. So it seems like in our case that the two weight variables should be it should be dependent of each other, or they should be related, but it's not necessarily the case. If we, for instance, print the weight in kilograms, so let's say weight in kilograms, and we say we add the weight in kilograms, and we also print the weight in pounds. Sorry, my keyboard is a little messed up. It keeps on missing keys. Or I type like a grade schooler, one of the two. Okay, so in this case, we're going to print the weight in kilograms and the weight in pounds. Now, what this will show you is that the weight in kilograms is 65 and the weight in pounds is still 132.66, meaning that they are not dependent of each other, because we actually changed the weight in kilograms after we calculated the weight in pounds, but it did not affect our weight in pounds at that moment. If you go and run that line again, then it will affect the weight in pounds, or the value you get. Okay, I hear somebody's mic unmuted. Do you have any questions? Okay, no questions.
No, it's fine. I think we are getting through. Okay, we are getting through.
Okay, no problem.
Thank you. Yeah.
Okay, so this part of our lesson is my talking time is finished for now. So what we're going to do now is the exercises. Now the exercises are for you to do it. I think for now, let's do it individually. We can do some breakout rooms, I think, a little bit later. So for this part, let's do it individually, and I'm going to give you a lot of time to do this, because I know the first part of learning something new can be a bit confusing. Okay, so I'm going to put everything in the Etherpad first, and then I'll discuss it with you. So if you have the Etherpad open in front of you, you will see that I'm typing in line 23 and I'm going down as I type. So this exercise, let's just call it 1. There's a few in the lesson, so I would like us to do all of them. And let's do lesson 2. Exercise 2, not lesson 2. Exercise 2. And I think there's 3. I'm not sure if there's 3 or 4. Okay, there's only 3. Now, if you've done any programming before, I think this will be a little bit easier. I'm not saying it's easy, I'm saying it's a little bit easier. Because I always say the most difficult programming language to learn is your first one. Okay, so you'll see that on line 23, there's written exercise. I'll take off the color just now, because I know the color sometimes boggles with your brain. So on line 23 onwards, there's a few exercises. And okay, what the hell? There you go. Okay, so the first part of our exercise is you are given a few variables. Let me just make them nice for you. And age, there you go. Now the question is, what values do the variables mass and age have after each of the following statements? Please do not overwrite my stuff. I see somebody just overwrote on my Etherpad here. Please don't overwrite on the exercises. I'll give you space to write. And let me just get back to the way it should be.
Please provide the link of the Etherpad here on the chat. I don't see it on my side.
No problem. Etherpad is in the chat.
Thank you.
There you go. Okay, so on the Etherpad on line 23 and downwards. So line 24 is, what values do the variables mass and age have after each of the following statements? Test your answer by executing the lines. Mass, age, mass equals mass times 2, and age equals age minus 20. So you have to execute this one by one, otherwise you won't be able to get the answer. Okay, so the values after each of the following statements, meaning that you have to do it line 1, 2, 3, 4. Okay, then the exercise 2 is Python allows you to assign multiple values to multiple variables in one line by separating the variables and values with commas. What does the following program print out? Okay, so please look at that. And then what are the data types of the following variables? Let me just make sure I put this as it is in the lesson, because when you copy and paste it, it doesn't take the next line always. Okay, so there you go. That's a little bit better. Okay. Okay, and then exercise 3 says, what are the data types of the following variables? Planet, apples, and distance. Okay, I'm going to give you 15 minutes to do this. It should not take you more than 15 minutes. So please do this and then make a note of your answers. And please do not delete the exercise. I want this to stay up for as long as the internet exists. So if you want to go back to the recording afterwards, or you want to go back to the lesson material, you have somewhere to look at the answers of the exercises. So I'm going to paste the answers in here as well, and we're going to discuss it afterwards. So it is 9:37 on my watch now. So I'm going to give you 15 minutes. So let's make it, okay, 9:38. So be back here after 15 minutes. So if you're done with the assignment, just hang out a little bit, and then we'll chat about it. Okay, it's almost been 15 minutes, so let's check out some of the answers, or let's look at the answers. I see somebody wrote some of the answers in our Etherpad, which is fine, but let's look at it in our Jupyter Notebook as well. Let me just get to that part again. Okay, so the first question was, what values do the variables mass and age have after each of the following statements? Test your answers by executing the lines. Okay, so the first line it says mass is equal to 47.5. So let's just print that as well. And we say mass. Okay, so mass is 47.5. Age does not yet appear on that line, so age does not exist as of yet. So our next line is age is 122, and you just write that, and we know that age will be 122. So if we say mass is equal to mass times 2, 0.0, it means that we are using the float board, and we want to print that to make sure what mass is, and we say mass, and we just write that. We'll say that mass is 95, and if we say age is equal to age minus 20, and we print that as well, we see that age will then be 102. Okay, so when you get to the next part, it says Python allows you to assign multiple values to multiple variables in one line by separating the variables and values with commas. What does the following program print output? Okay, so if we look at first and second is equal to Grace and Hopper. Okay, and we say third and fourth, and fourth is equal to second and third, second and first, and then we want to print the third and the fourth. So when you look at your variables, what you assigned was first is Grace, second is Hopper, third will be.
There's a typo there in the second line, the last one.
Okay.
Yes.
Thanks. There you go.
Awesome.
Okay, so first is Grace and second is Hopper. Third is equal to second, so third is equal to Hopper. And fourth is equal to first, so fourth is equal to Grace. And then we want to print the third, which will be Hopper, and the fourth, which will be Grace. So when we run this, you will see that it is Hopper Grace. Okay, then they said, what are the data types of the following variables? So we said planet is equal to Earth. And the next one said apples, or yeah, are equal to 5. And distance is equal to 10.5. Now, if you've worked with numbers in the past, you can with variables in the past, and you can off the cuff say planet is a string, apples is integer, and distance is a float. But let's just make sure. So let's print the type for planet, and let's also print the type for apples, and we print the type for distance. Okay, let's run that, and you will see that there's a string, an integer, and a float. Any questions for that? what questions do you have with regards to the first part of our lesson? We went quite slow because I have a massive audience, so I want to make sure that everybody stays up to date. We normally don't have 25 odd people in an online class, so just want to make sure that I give everybody enough time. Okay, so it is almost 10 now. Let's take a 10-minute body break before we get to the next part of our lesson, which will be actually working with our data, analyzing our data. So let's take a 10-minute break, get some coffee, stand up, walk around, get some water, and then please be back here at 7 minutes past 10. Okay, welcome back, everybody. I hope you got some water, some coffee, and so on. The next part of our lesson that we're going to do is analyzing patient data. So on our notebook, I'm just going to make a comment and say we're going to start with analyzing patient data. Okay, you'll see that my wording that I typed there is a light bluish color, because I put the hashtag or pound sign in front of it. It is a comment, excuse me, which means that Python will then ignore that part. So even if you run this, it will just open a new line. So that means that it's a comment, and you can use that in front, above, behind. You can use it anywhere you'd like to keep track of what you're doing. So the comments are quite important when it comes to programming in any sense, because if you come back to your program in a few months from now, you won't necessarily know exactly what you did. So the comments will help you understand what your train of thought was, the way you approached it, and so on. So please remember to use comments if and when you like. Okay, so when we look at analyzing patient data, there's a lot of things that you have to take into consideration. So what we start with is loading the data and using the libraries to call data in and so on. So the libraries part that we want to use now is Numpy. These libraries are already predefined, like certain functions. They're already written for you, and you can just call them up and use them. We have the same situation when you use R for statistical analysis, so on. There's a lot of libraries that you can just call up and use. So in our case, before we start with anything data related, please import Numpy for me. Although Numpy is already predefined and it's already a library, you need to import it to tell your notebook to say, okay, I want to use Numpy. So please do that. And when you press Shift and Enter, it will then import Numpy, meaning that we can use that library now. Okay, so Numpy is called numerical Python. In general, you can use this library when you want to do some fancy things with numbers, or if you have matrices like we do, or like we have, or arrays and so on, to work with a little bit more deeper than just basic arithmetic mathematics. Okay, so importing a library like this is, when you look at it in a physical sense, it's like taking a piece of lab equipment and out of a storage locker, putting it on a bench and using it. So it is always there. You don't necessarily use it until you import it. So you don't necessarily use every piece of equipment in your lab every day, but they are there if you'd like to use them. So libraries provide us with additional functionality. It makes Python a little bit more interesting, and it also makes it a little bit more versatile within this programming environment. Okay, so when we start with Numpy, the library itself, within that library, there's a lot of functions contained within it. And you can see it as sort of a parent-child directory situation where the parent is in charge of a lot of functions. So in this case, Numpy has, for instance, something that's called load.txt that we want to use now. So the way you call it up is you tell them, I want to use this library, and within this library, I want to use that function. Okay, so numpy.load.txt, and then we're gonna use a file name, fname is equal to information01.csv, which is in our data. So you call it up information-01.csv, and you say I want the delimiter to be a comma. Okay, so it is in line with what's already in that file. In that specific CSV, everything is already delimited with commas. So we just make sure that we stay with that within that parameter, and then we press Shift and Enter. So it will give you an array, and you will see that it gives you a piece of the array. It doesn't give you everything. It gives you the first three, rows, and the last three rows, and you will also see it gives you the first three columns and the last three columns of each of that row. Because that array is quite big, it will take up the whole screen. So this is just a preview of your data that you have. Okay, so this expression, numpy.load.txt, is known as a function call that asks Python to run the function load.txt within the NumPy library. If I can if I can use the analogy, if your name is John Smith, then it means that you are the John belonging to the Smith family. So load.txt is the function belonging to the NumPy. Yes, Kingsley, it's really important to add the delimiter, otherwise you might get some gibberish on your screen. Okay, so coming back to the function and the library. Load.txt is contained within the NumPy library. It's like going to a library and taking out a book within the library. You're in a specific library, and the book, in this case, load.txt, is just a small part of that library. So coming back to analogy in the lesson, if they say your name is John Smith, you are the John belonging to the Smith family. So you're just one John in that bigger family. So when you call up this person, you can use smith.john, like we do numpy.load.txt. If you use the library analogy, you can call the library.book. Okay, so that's the way we always call it up, and I think that's sort of the go-to way in a lot of programming languages. Not all of them, but in a lot of them. I know in R, for instance, it's also done that way. Okay, so when you look at this data, it does not make sense yet, but we're going to work through it and see what we can do with the data. Okay, so what we want to do is we want to see what type of data it is first before we can work on it properly, because you can't do mathematics on something that you cannot actually see. You can't do a lot of functions. You can't use the data if you don't know what type of data it is. So if we say, like we did previously, print type data, and we run it. Oh, what did I do wrong? Oh, that's what I
You
did wrong.
didn't assign
Yeah.
data when you loaded the text.
I did not. You're right. Thanks. Okay, so as previously, numpy.load.txt shows you the data, but it did not save it anyway. So what the step I missed was you have to assign it to a variable. So let's assign it to a variable data, and we say numpy load txt, numpy.load.txt, and we say file name is equal to information dash 01.csv, and our delimiter is equal to a comma. Okay, so if there's no typos, that should run properly. Nope. What did I do wrong this time?
Type in inflammation.
Say thank you very much. Inflammation. There you go. Okay, so now data is assigned that array. So that array data has the value of that array. So if you print it out,
Okay, sorry.
yes, speak with me.
On my site, it gives me some error when I try to load that data.
When you use the numpy.load.txt.
Yes.
Okay. When you created your notebook, did you navigate to the part where you can see the data that we downloaded?
Yeah, I see the data because I tried even the copy path, but I don't know why it's not working.
Okay, would you mind sharing your screen with me so I can see?
Okay, let me just share.
Okay, I'm gonna stop my share so that you can share.
Okay. Can you see my screen?
Yes. Okay, so let's see what the error CSV not found. Okay, so it does not find your information.csv.
Yes, because I tried doing this one, like a copy path, then I did it. Still it says the very same thing. I don't know what I'm not doing.
Okay.
Okay.
Could you try doing it without saying desktop / at the start?
Oh, okay. Let me.
Put the slash in front and run it again. Okay, still not.
So remove desktop and the /.
Okay.
So in other words, just data, then inflammation.
Without the / at the beginning?
Okay, remove the slash.
There
Oh,
you go.
Okay, there you go.
okay. Thank you.
Okay, thanks, Stuart. Okay, you can stop your share, so I'll start my share again.
I stopped. Thank you very much.
Okay, let me just get everybody back on my screen. Okay, there you go. Okay, Jade says that he did the same, just added the full path. Okay, so sometimes it will give you you will need the full path. Sometimes you can get the relative path, or you can just use the parent directory that you're in. It will depend on system to system. Okay, so now if we say print the data and you run it, it will give you the same output as when it gave you when you just loaded the txt. But in this case, it will not tell you, it will not say array in front. So if you want to see what the data type is, you print type data. And if you run this, it will tell you it's a numpy in the array. Okay, so you're not really sure what type of data it is. This output tells you that the data is currently an n-dimensional array with the functionality of which provided by the NumPy library. And this data corresponds to your inflammation patients. And the rows of the individual patients, the rows are the individual patients, and the columns are the days, as we said previously. So if you want to look at what the data is within the arrays itself, within the array itself, you can say print data.dtype. and it will tell you it's a float 64. Okay, so within that array, your data is in the float, is a float type, okay, or a floating point number. Okay, so the following command you can also use to see what the shape is. Remember we said that we have 60 rows and 40 columns, but if you do not know that off the bat, or if you have a massive system data, then you can say data.shape, because you won't always know exactly how many columns, how many rows you have. Because when you look at, for instance, in the bioinformatics environment or the microbiology environment, you might have a few thousand lines or a few thousand columns. So the way you see your shape is you say print data.shape. In this case, it tells us we have 60 rows and 40 columns. Okay, so before we go further, I want to show you the way that Python puts the data. Okay, sorry, I'm just reading the comments. I see there's a question there. What will print out in the array as different types?
Sorry for the typos. Let's say the array doesn't have just floats or integers. It has both strings, floats, integers. What will print out with the data.d type?
Okay, I would say that before you start working on your data, I would say you have to clean your data first. So it will, for instance, what the data type I'm thinking of now is if you have floats and you have integers and you have strings, maybe if you have a person's name, number, age, weight, all of that. So I think it should show you what the different data types are. In this case, we only have the float numbers because we're only working on information numbers. It's only one variable we're working on. But in most cases, if you want to work on data in such a way, you're only going to focus on a specific type of data. You're not going to work on everything all at once. So that's where data cleaning comes in. I don't think in the software carpentry part of the material there is data cleaning and all of that. When you go to the data carpentry part, we do a lot of lessons on data cleaning and how you clean your data. But it should show you all the different types of data that is in that array. Okay, I see Renee sent us a message. Hi everyone, my director called me now and say he will be on a flight Friday morning, so he will be joining us tomorrow when we start to meet all. I remember asking everyone to please introduce yourselves to him so that he knows who is working on what. Also then, while he is here, we might want to take a workshop photo. Could Michael and Ruth also be there to briefly just for the photo? I will email them to ask. Okay. If they want to be there, I don't have a problem. So everybody just tomorrow morning, have a brief introduction of yourself for Renee's director before we start with the workshop. Okay, so I'm going to throw this over to the screen. I hope you guys can see this colorful display now in the lesson. Okay, so when you look at Python, the way Python looks at data, Python starts at 0 and then continues on for rows and columns. Now, a lot of different programming languages like Fortran, MATLAB, and R and so on starts with 1 on the first variable or the first entry. But within the C family, for instance, C++, Java, Perl, Python, and so on, they start at 0. The reason that the other programming languages start at 1 is because for thousands of years, when we count as humans, we count from 1 and not 0, 1. We count 1, 2, 3, not 0, 1, 2, 3. But when you look at mathematics, for instance, when you look at matrices in mathematics, you start at 0, then 1, then 2, then 3. When you look at that part of it, it's 0. And because C is one of the older languages, and Python is within that family of programming languages, they also start at 0. So when you look at our data, for instance, we start with columns first. In other words, is the green line here, columns, rows, not, excuse me, my English is failing me. We start with the rows first, then we start with the columns. In other languages, you do start with the columns first and then the rows, but in Python, you start with the rows first and then the columns. So getting back to our data type, you start with specific patients first, and then we start with the days. So if you want to refer to this first column, the first entry there, which is A, you're going to refer to row 0 and column 0. If you want to refer to entry B, you're going to start with row 0 and column 1. If you look at your data here, data 0, 1 equals B. If you look at E, for instance, it will be row 1 and column 1. Okay, if you look at I here, it will be row 2 and column 2. Okay, so remember that as we go forward, we're going to work with columns first, then rows second. Also, then when you refer to your data, it will be, firstly, you're going to say the row, then the column. So the position within the row that you want to refer to, and then the position within the column that you want to refer to. What I'm saying is, if you look at row 0 and I want to refer to B within row 0, you're going to say 0, 1, because you're going to count, and then that will be within that specific row. But then if you go to the columns, you will refer to the column number and then the element within that column. So let's see how that works when we go to our data. Okay, so I'm just going to put this back, and then we're going to work with this. So coming back to our data, we have 60 rows and 40 columns. That's why it's 60-40. So meaning that we have 60 participants over 40 days, or 60 patients over 40 days. So if you print the first value in your data, okay, see, typo, it happens. Mistakes happen. We're all human. We do make typos. We do make mistakes. So please don't take that personally. If you make a mistake, just move on. Okay, so our first value in the data is 0, 0, and see what we get. Our first value in data value is 0.0. Okay, so the first element in other case, when you look back at our data here, the picture I just showed you is 0, 0, which is A. Okay, which will then in this case be row 0, column 0, and the value of that will be 0.0. Okay, so when you look at the middle value of your data, I mean, in other words, the middle of the data, the middle of your rows and the middle of the columns, which will be in position 30 and 20. So it's a middle value in data. And we say it's data 30, 20. Okay, Kingsley, I will explain it in a few seconds, and you will see that the middle value is 13. Okay, coming back to the types of brackets. When you use the normal brackets that we all use in typing and wording essays and stuff, that will be the ones highlighted in green at the moment. Those are the normal brackets that you use to put in your arguments. Okay, when you work with arrays, then you will use the square brackets. So the square brackets will then give you a position in the array for where you want to work with. So the square brackets are mostly used in arrays. I don't know if it's only used in arrays in Python. In Java, for instance, you can use it for only in arrays because you use the curly brackets for something else. So when you look at our data at the moment, the normal brackets is where you put in your arguments. Now, argument is this, for instance, is seen as an argument where you put your what do I want in there? What do I want to take out of this print situation? So in this case, we said the first value in the data should be printed, and then we said we gave it a string, first value in data, and we said the data in our array, which is then in the square brackets, will be in that specific position. In the last line, it was in 3020. I hope, Kingsley, I hope that's an adequate explanation. If you have another explanation, you are more than welcome to explain it as well. Okay, one thing to mention for those of you who've never been to a carpentry workshop or not necessarily as familiar with the carpentries, we as instructors are not necessarily programmers. I'm not a day-to-day Python programmer. I've done Python programming a few times, but I'm not a programmer per se. But we have a saying that we just need to be one step in front of most of the participants. Now I know most of you are a few steps in front of me, but that's fine. That's the dynamics of a workshop. You always get learners that are complete novices. You get some learners that have been doing this for a few years, and you get some learners, the learners that have taught themselves a trick or two. So I don't know everything about Python or Numpy, but I do know enough to get you to a point where the lesson wants to get you to. Okay, so coming back to our lesson, the next part of our lesson is slicing data. So an index like 3020 selects a single element, but a lot of times you would like to select multiple elements. You would like to select a whole row, for instance, or a few rows, for instance. You don't only want to select a single element. So how do you select a row or column, a few rows with a few columns in it? And that, the next part is how we do it, and that's called slicing the data. So what it actually means is you slicing the data into specific chunks that you want to use at a specific moment. When you work on data, or when I work on data, I don't always work on the whole data set. I work on a subset of the data. So sometimes you would just like to have a specific part of your data and work on a smaller set instead of the whole thing every time. So that's called slicing the data, of slicing data. So the way you do that is, just to print it out, we're going to say print, and then you call up your array, you say data, and I want 0 to 4 in the rows, and I want 0 to 10 in the columns. Okay, and I'm going to explain to you what it is, but the best explanation is to get the output first, and then we can explain it from there. Okay, so you'll see that there are 4 rows and there should be 10 columns. But the way that you call columns and rows up in Python is you start at the first element and then you get to n-1 element. So in our case now, remember we start counting at 0, but we said we want 4 rows. So this is where you start is 0. In our case now we start at row 0 and we go to row 3, but we want 4 rows, meaning that 0, 1, 2, 3. So the number you put in there, in our case 4 and 10, is the amount of numbers or amount of rows that you would, the amount of rows or amount of columns that you would like to see. But please remember that you will always start counting at 0. So you will not see row 4, you will see row 1, 0, 1, 2, and 3. Row 4 will not be there because we start counting at 0. Then the same thing for the columns. We wanted 10 columns out of the 40 columns, and we wanted the first 10, meaning we started at column 0, and we go into column 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the first part is where you start. The second part is how many rows or columns you have. Okay, I hope that explains the way we call up the data. Now, we don't necessarily want to start at row 0. Sometimes you want to start at row 5, for instance. So let's start at row 5, and we're going to see 10 rows, and we want to see column 0 to column 9, or from the first column to the 9th column, or to the 10th column. Okay, invalid syntax. I did something wrong. Anybody tell me what I did wrong? Yeah, I closed the brackets.
Yeah.
Okay, so always remember syntax is quite important when it comes to programming. What I did now was I wanted to call up 2 arrays, but I did not specify the second array. So the first array went through from 5 to 10, and the second one didn't. So, okay, coming back to what we actually want to do is we want to see row 5, and then from there we're going to start at row 5, and then from 5 we want the 10 following rows, and then we're going to start at column 0 to the 10th column. Okay, so there you go. So you'll see that from 5 to 10, so in any case 5, 6, 7, 8, and 9, you see 5 rows, and you still see 10 columns, 0 to 9. Any questions with regards to how to call up specific parts of the array? I can just do, okay, but I'll just do a quick recap in any case. If you use the array just as is and you say data 3020, like there in line 30, then you're calling up a specific value. You're calling up one element. If you then go to line 31 and you see that you use data, and within your square brackets, you use the following argument with a colon. You say, I want to start at row 0. I want to go 4 rows deep, and then I start at column 0, and I want 10 columns, the first 10 columns. Then you call up specific parts. You don't always need to call up a specific element. You can call up bigger parts of your array as well. Okay, you don't always have to include the upper and lower bound on the slice. So if you don't include the lower bound, Python uses 0 by default. And if you don't include the upper bound, the slice runs to the end of your data. And if you don't include either, it includes everything. So let's say we want to make a subset of our data. We call it small, and you say data small is equal to data, and we don't give it a lower bound, and we say 36, and we don't give it an upper bound. So what this will do is it will start at row 0 and go to 0, 1, 2, and then it will start at column 36 and go to the end of our array. Okay, so let's print this. Let's do this. Small is, and then we call up small. Okay, so there you can see small is the 0, 1, and 2 column rows, and it has 36, 37, 38, and 30, oh no, it's 37, 8, 9, and 40. The columns. So it's the last 4 columns and the first 3 rows. Okay, so it's because we have a relatively small data set, you can think of it that way, and you can actually go in and analyze it and see what you have. But if you have a bigger set, it won't always work that way. But in our case, this is just to show you that you can say a start point and not give an end point for your columns, for instance, and it will give you from there all the columns that are left. And you can say that you want to start at the very beginning, but you don't necessarily have to put the 0 there. Okay, so coming to analyzing data, Numpy has a lot of different functions that are useful that we can do operations on. For instance, basic statistical analysis is part of Numpy as well. By basic statistical analysis, I mean things like minimum, maximum, the mean, or the average, as laymen call it. So there's a lot of things that Numpy can do for you that you don't necessarily have to do for yourself. So, for instance, if we say print numpy.mean on data, then we will get the mean of the information, and in this case it will be 6.14. So mean is a function that takes an array as an argument. So you can, with mean, you can get you can use it within that array. Okay, so not all functions within Numpy or within Python need arguments or need input. There are standard things that you can just put into your code, and you don't need necessarily need to put in arguments or need input. For instance, if you want to know what the current time is, sometimes it is useful when you run programs to know the time and date when the program runs. So in this case, you can import a library called time, and we can print the current time. So what you say is time, excuse me, dot C time, which is current time. And if you run that, it will give you Wednesday, April 6, 10, 43, 35, 2022. Okay, so this function does not need any arguments at all. This is just to show you that not all functions need arguments, not all functions need input. Some of them just have arguments by default. Okay, so some other NumPy functions that you can get descriptive values on the dataset. You can use a lot of different functions as well. And we also use multiple assignment within Python to get this much easier. So if you say that we want the max value, remember the second exercise, we said that you can use one argument to assign a lot of values to different variables. So let's do that as well. So we say that we want the max value, we want the minimum value, and we want the standard deviation value. So we say that the first one is numpy.max data, max of data, and numpy.minimum of data, and numpy.std for standard deviation of data. And we can print the maximum, sorry for that, maximum inflammation and let's use Maxwell, and we want to print. I'm gonna make different prints because I want them to print it on different lines and not all in the same line. Minimum inflammation 80, and it's minval, and we print the standard deviation. STDval. So if you run this, you will see that the maximum information is 20, the minimum information is 0, and the standard deviation is 4.6. And there's a lot of different floating point numbers behind that. Okay, so there are certain functions that are already defined for you, as we previously said. So max, minimum, standard deviation or STD, current time within time situation, mean. There's a lot of things that are already there for you. Okay, so we spoke a little bit about comments already, so I'm not going to cover that part now, because a comment is just you telling yourself what to do, what to remember. So in case if you want to do that, you can say maximum, for instance, maximum, in this case minimum. I know this does not make sense to do this now because we already have it in the print, but I just want to show you that it does not impact anything at all. So if you run it again, it just gives you that. So comments can be in front of your text, can be behind your text, it can be above or below. It cannot be within your brackets. For instance, if I want to put a comment in there, it's just going to print it as a string. Okay, so comments should not be within inverted commas or within your functions. It should be behind or in front or above your functions. Okay. So when you look at our array and you want to work with specific parts of the array, you can also then do a maximum, minimum, and standard deviation with each patient or with each column or with each row as well within this data set that we have. So you don't need to take the whole data set as it is. So we can combine a few functions and do that as well. So let's print the maximum inflammation for patient number 2. Okay, so how do we call that up? We say numpy dot max, and we use our array brackets. We use normal brackets first, and we say a data dot. We use our array, so patient number 2, and we just want all the data. Okay, so let's run that. So the maximum information for patient number 2 or patient 2 is 19. So that we can make that a little bit nicer. And there you go, there's a colon separating it. So what if we need the maximum information for each patient over all days? So over all 40 days for all 60 patients. So let me just show you the lesson again. So as in the next diagram on our left side, if we want the maximum information for all of the patients on the left side, or the average for each day as on the right. So how do we do that? So when you look at this, we want to, in this case, we want to use the rows if you want to work with the patients. And if you want to use the days, we have to work with the columns. So that's going to look a little bit different when we start with our functions. So to support this functionality, most of our functions are going to work with the axis, and we're going to go with axis 0 here and axis 1 over there. So everything is in two-dimensional. It's a two-dimensional array. In other cases, we have rows and columns. We don't have depth in it, so it's a little bit easier to work with. So coming back to our notebook, let's work on axis 0. So when you look at this output, axis 0 should be the columns and axis 1 should be the rows, but according to the diagram. So let's look at this. Print the mean numpy dot mean for our data on axis 0 dot shape. Okay, no, just dot axis 0. Sorry, I skipped one of the lessons again. So in this functionality, we should get, or in this case, we should get the mean for all of the patients, right? Because they said, no, for all of the columns, because it's axis 0. So meaning all of the days, the mean for each day, we should get the mean for each day on axis 0, axis with a S. Okay, so let's run this. And the output we get is the mean for each day then, when you look at that, all of the columns. Okay, then we can look at what shape this is to make sure that we have the correct axis here. When you look at the shape of this, it should be then 40 columns. So if you look at our print, you can say print numpy dot mean from the data on axis 0, and we want the shape. You say dot shape, and if you print that, it will tell you 40. So it means that it is the information per day for all the patients. So we want also, sometimes you want to see the patients themselves and not just the days. So we say we print our mean. So it will be numpy.mean for the data on axis 1, meaning that all the patients, not the days, but the patients themselves. And if you print that, you will see that the mean for all the patients is written there. If you also want to double check that, you can then use the shape function, and it should give you 60. Okay, so this is the average or the mean inflammation per day for per patient across all the days. Yeah, and then the first one is the mean inflammation for all the patients per specific days. Okay, so next we have a few exercises. So the first one is slicing strings. It's already in the Etherpad. I'm going to paste the others as well. Just going to read through them quickly, and then I'll paste them. I think this is a little bit more interesting than the first ones, and then we can discuss them after you did it. Okay, so the first one is called slicing strings. A section of an array is called a slice. We can take slices of characters, strings as well. So they give you the script, and they give you the output, and then they ask you a few questions around it. And then thin slices, let me also paste that as well. Okay, thin slicer says the expression element 33 produces an empty string, i.e. a string that contains no characters. If data holds our array of patient data, what does data 33,44 produce? Okay, so they ask you to work on the data itself, and then the one following that is called stacking arrays. Arrays can be concatenated and stacked on top of one another using NumPy's vstack and hstack functions for vertical and horizontal stacking respectively. And then they show you the Python, and they show you the output, and they say write some additional code that slices the first and last columns of A and stacks them into a 3x2 array. Make sure to print the results. Okay, so I'm going to paste this as well in the Etherpad. Hopefully this does not go haywire again. so that's the first part, and then let's see if we can get the output properly. Okay, the output looks sort of normal. Okay, then the question is write some additional code so that you can stack them. And I'll paste that as well. And then change in inflammation. There's also a question about change in inflammation. The patient data is longitudinal in the sense that each row represents a series of observations relating to one individual. This means that the change in information over time is a meaningful concept. Let's find out how to calculate changes in data contained in an array with Numpy. Okay, and then it gives you the thing to do. So I'm going to paste that as well. My changes in inflammation, that should be there. Okay, so this is the output. Sorry, it takes a while to get everything in the Etherpad. There you go. Okay, just make sure we know what the output is and what the input is. Output, that's output as well. And okay, so there you have your exercises. There's a few others that I want to do as well. That's one, and there's another one. So I know this might be quick and easy for some. I just want to say quick, not necessarily easy. Some people work faster than others. So I'm going to give you half an hour to do this. It is almost 11 now, so I'm going to give you until 11:30 to do this. And then we'll start with the next lesson. The next part of the lesson. I want to see if we can be done around about 12:30 today. I also have to go back to the office and so on. And I know a lot of you have other work to do and you can't do this the whole day. Okay, so let's do this. I'm going to give you half an hour. Slicing strings, thin slices, stacking arrays, and changing information. If you can't get to everything, don't stress about it. Don't worry about it. I'm going to give you a link to the part of a lesson where all the solutions are. And you can go through the solutions and we can discuss it tomorrow as well if you'd like to. And then be back here at 11:30. Okay, everybody. Hopefully you got that right, or some of you are still busy, most likely. Okay. So in the Etherpad on line 144, I gave you a link to the lesson that we're doing. And if you scroll down to the lesson, you will find all the solutions that you would like. So I'll put that over on the shared screen. So if you look at the screen now, you will see that we were busy with analyzing patient data. And if you go down all the way to where our slicing strings start, you will find that there is a solution to each and every question that they asked. So you can go through that when you're done with the workshop this afternoon or so on. And if you have any questions, my email is in the chat, and we can have a chat about it and see how we can help you with the questions. And alternatively, we can also quickly discuss it tomorrow morning before Stuart starts with day 4 of the lessons. Okay, so I'm gonna go to visualizing tabular data. We're gonna talk for a little while, and then we're gonna do some exercises again. But this is the last part of today's lesson. So let's get started. By show of hands, do any of you have any questions? You can just do a reaction or put up a tick. If there's any questions, any uncertainties, anything you would like to ask or bring under my attention, you're more than welcome to do so at any time during the lesson. You can simply just unmute yourself or type in the chat. The chat is open on my screen, so I'll be able to see the chat as well. You're more than welcome to interact with me at any time. I don't want this to be a situation where I bore you to death and you struggle, or you don't feel you can interact with me. You're more than welcome to send me an email anytime from now on until I cease to exist. So don't feel like you can only send me an email with regards to the specific carpentries. You can ask me anything. Okay, if I don't know, I know a lot of people within the carpentries, so I'll most likely find you an answer somewhere. Okay, so getting to visualizing tabular data. Now, as you know, we were working with our 60 by 40 matrix, which in essence is tabular data. We're working with patient data, and we have 60 patients that have been observed over a 40-day period. And we would like to visualize this because you don't know if there are outliers really in your data. You don't know if some of the data is maybe faulty, or if you have issues. Sorry for the dog. If you have issues within your data, sometimes to visualize it and analyze it visually helps you a lot. So what I would like you to do now is import matplotlib.pyplot. Now there's no, I want to say there's no de facto standard plotting within Python, but matplotlib is sort of became the standard in the last 2 years to do the plotting. So we're going to use matplotlib. There are a few others as well, but we have found that matplotlib works quite well. So please import matplotlib.pyplot, pyplot, matplotlib.pyplot. Okay, once you've done that, okay, I might have an issue. Okay, there's no issue, just ignoring the UTF-8 not a valid region tag. Not really an issue at the moment. So if you get that, you should not stress too much. It will still work. Yes. Okay, my mic is muted again. Okay, so then what we want to do is we want to visualize our data in a way that we can start analyzing it. So what we're going to do now is we're going to say image equals matplotlib.pyplot.im show, and we're going to use data because we still have the data. And to physically see it, you have to show it. So say matplotlib.pyplot, and we say show a dot show. Sorry for that, dot show. And we don't need an argument because it will automatically use the argument. Okay, so what the matplotlib.pyplot function does is it it shows you that you can, okay, there's a typo. It enables the ability to of Python to make a Y and a X-axis and plot something on that you can actually see. Now there's a different, there are lots of different plots, as you might know. You get line graphs, you get histograms, you get a lot of different plots. But for now, we just want to see the whole data set within one plot, and then we can start working on it as we go along to get a little bit more data. So let's run this. And what you should see now is small, okay, depending on your screen size, but a small plot with all the data sets. So each row in this heat map. So this is a heat map, meaning that it will show you the low inflammation values and the high inflammation values. And the yellowish pictures, or the yellowish pixels, shows you the higher values, and the darker or bluer to black almost shows you the lower inflammation flare-ups of the patients over the 40-day period. And within this, you can see that it goes up, and the inflammation goes up, and then the inflammation goes down for all of the patients over this period. So within this this data set, this Dr. Maverick claims that the patients take the medication once the inflammation flare up begins, and it takes around 3 weeks for the medication to take effect and begin reducing the flare-ups, and flare-ups appear to drop to 0 by the end of the clinical trial. So now let's take a little bit of a look at the average inflammation over time. Now, how do you do that? Let's assign it a value. Average inflammation is equal to numpy dot mean, because we're going to use numpy to get the mean from data, and we want axis 0 because we want it over time, meaning that the days, and we want the average plot. So okay, I see I used AVG and they're using AVE, so let's stick with the lesson and use AVE. AVE plot equals matplotlib dot pyplot dot plot, and we want to use the average inflammation. Okay, and then we have to show our matplotlib as well. Okay, so if you run this, you should see something that looks sort of like a mountain range. This will then show you the average inflammation per day across all patients, okay, which we saved in average inflammation variable. Then when you use the matplotlib.pyplot function, you create this function and you create a line graph for those values. So you will see that it's sort of a linear rise and fall over the 40-day period, and this doctor claims that the medication takes around 3 weeks to take effect, but we don't necessarily take everybody's word for granted. So let's look at some other statistics to make sure if the data is really correct or not, because you do get some made up data here and there every now and then. So let's do a max plot. So this will then plot the maximum temperatures, or the maximum flare-ups actually, over this period of time, equals matplotlib. So max plot equals matplotlib dot pyplot dot plot, and what we're using is numpy dot max, and we want to use the data that we already saved, and we're going to do it over time, or axis 0 over the days. And remember, we have to make sure, okay, bracket, we have to make sure that we show this plot. So matplotlib.pyplot.show. Okay, so when you use that, then you'll see that this is sort of a pyramid, meaning over time it goes up and it comes down linearly, which is sort of shaky, but okay. Let's look at the minimum amount of flare-ups over this time. So let's say minimum plot is equal to matplotlib.pyplot.plot, and we're using numpy.min, and we're getting the data from our data set, and we're still using the flare-ups over time. You're more than welcome to copy and paste as well, because we're doing mostly the same thing a few times. So you're more than welcome to copy and paste and just change what you need to change. But I'm going to try and type as best I can for as long as I can. Okay, if we plot this, this will give us the minimum flare-ups over time, over the 40 days. And I might have an error somewhere. Oh yeah, plasma. It must be plot, not plasma. Sorry for that. It should be matplotlib.pyplot.plot. And there you go. Now you see sort of a step-by-step pyramid. So neither the minimum or maximum trend seems likely. So either there's a mistake in the calculation or something's wrong with the data. This insight would not have been seen if we just looked at our tabular data. That's why graphs in your research is so important. That's why if you can include stuff like this, because this will show you if the data is correct or not, and if your analysis or hypotheses and so on can be accepted or rejected and so on. Now, if you look at plotting, just the plotting, let's forget about the data a little bit and just look at these plots. And sometimes you would like to have these plots in one piece of paper, and the days of cutting it out and pasting it in is long gone. You can take maybe if you would like to screenshots and make your own, but let's see if we can plot them together in Python. Now, what we would have to do is you have to call up your data. So if you see that there's an issue anytime that NumPy does not function properly, or Matplotlib doesn't function when you open your notebook again tomorrow or so on, you can simply just go and import NumPy and import Matplotlib again, and it should then load those libraries for you and so on. So what we would like to do now is group similar plots in a single figure using subplots. Now, instead of each of them have their own space and their own plot on its own, we want them to sit next to each other or on top of each other. So what we're going to do now is we're going to plot them next to each other. We're going to do the average, the maximum, and the minimum plot, and we're going to put them all in line, the same row, just different columns. Okay, so when you look at the data that we have, we don't need to load it again. You can load it if you'd like to, but we already have it. Okay, so let's create a figure, and we call it and we define it by using matplotlib.pyplot.figure, and we say the fig size is equal to 10.0, 3.0. Okay, I'm just going to make space there. Okay, so the fig size will tell Python how big to make the total space. And each plot will then be placed within that figure by using a different function called add subplot. So let me just make sure that I don't make typos this time. So what we're going to do is we're going to make 3 axes, axis 1, axis 2, and axis 3, and we're going to add subplots to a subplot to each axis. So axis 1 will then be equal to figure.add subplot, figure underscore add, excuse me. So figure underscore add dot subplot 1, 3, and 1. Okay, so what this access figure.add subplot parameters tell you is, the first one is the rows. We always work rows first, then columns second. So it'll tell you we only want 1 row, but we want 3 columns, and this will be figure number 1. So this will be in position number 1, column number 1. Now, if you add access to, you also say figure add underscore subplot, and you say still 1 row, 3 columns, but this will be in column number 2. And then if you say access 3 is also figure dot add underscore subplot, and it will be 1 row, 3 columns, and this will be in column number 3. Now next we're going to define what these axes should be and what type of graph it should be, any labels and so on. So what we're going to do is we're going to work with axis 1 first. So axis 1 dot set y label, set underscore y label. So this will label the y axis, and this will be the average plot or the mean as we did firstly. And then we say axis 1 dot plot, and we say numpy dot mean. Yes, and we say we get the data from our subset or from our set data, and we're looking for data over time, which will then be axis 0. Okay, then we go to axis 2, and we say we set the y label to maximum or just max, and we say axis 2 dot plot, and we say numpy dot max, and we get the data again from data, and we're looking for the data over time. Okay, as you can see, I made a little error there, and then we will need another bracket at the back. There you go. Right, and then axis 3 will then be the minimum. So we set the label at minimum, and we say axis 3 dot plot. Just fix my typos. Plot, and then we say numpy dot min. We get our data from the data set. We're looking for the data over time, and that should be our 3 figures. Okay, so what we would like to see is that something called a tight layout, meaning they should be close to one another. So you should be able to see them on one page. So we're going to say figure.tight layout, and we don't need arguments because it will take the arguments from the figure variable, and then matplotlib. We can save it as well if you want to, but let's just see how it looks. So what we will have to do is we will have to show.
There's a typo on axis 3.
Okay, thanks.
Here on the numpy.
There you go.
Numpy on the axis 3 dot plot.
Okay, so there were actually two typos. Okay, that should fix it. Thanks. Okay, and then we want to show. Let's see if it works. Okay, so there you go. You see that there are 1 row and 1, 2, 3 columns. So that's what we did there with the subplots. So all of these will then be subplots within a bigger frame. That's where we had to say the figure size. So the figure size on top there will then will define the whole frame, meaning this whole frame, 10 by 3, and the subplots will then be loaded into that frame. So you can make the frame as big as you'd like to, and then the subplots will then just appear a little bit bigger. So then this is the average plot, the maximum, and the minimum plot. So if you want to save this, you can save it in your in your script, you can say matplotlib.pyplot.save figure, save fig, and you can call it whatever you'd like to call it. So I'm going to call it inflammation.png, and when you run it, it should save it. So when you go back to your data, you should have an inflammation.png here, which you then can open, and then the plot is saved. Okay, so that's how you can save it and sort of export it so you can use it in your article or wherever you'd like to use it. Show it to somebody and tell them, okay, this is what I found, and so on. So that's how you make subplots and singular plots. Okay, so just a quick recap. The load.txt reads the data from your library and then tells the plotting library what you want to plot. When we created this 3 subplots, it was done within a bigger frame. And then when you say title layout, it squeezes them together closely, because as you can see, you can most probably add another plot in there as well, and it will be able to fit on one page. So this is always okay. Pierre is asking, can we animate this plot? Okay, Jade, I'll get to your question right now. Stuart, do you know anything about animation and plotting within Python?
I think I've done it once before with matplotlib, but it's very awkward and difficult to do. And I think there's other libraries that are better suited for animated plots.
Okay. Like I said, matplotlib is I want to say the quickest way to plot something in 2D. I would suggest using something else to animate this as well. I'm not necessarily sure exactly which one, but I'll look it up and then we can talk about it tomorrow, if that's fine with you, Pierre. Okay, then Jade says, good morning. I'm not sure if it was mentioned. Could be easier to say import matplotlib.pyplot as PLT. Instead of just importing it to avoid to type it all out again. Okay, so what you then do is you import it as with a shorter name, like it's mentioned there. This is also part of the next part of the lesson. They say we use matplotlib.pyplot to import the pyplot. However, we can use shortcuts such as PLT to make it a little bit easier. I think the reason we do it the way we do it in the lesson is just to get that function a little bit set in stone in your long-term memory, because we forget a lot of stuff if you just quickly do it. So if we import it as just as PLT, after a while, when you come back tomorrow or so, you want to use PLT and it won't necessarily work. So yes, it is a good idea to import it as PLT to save time in typing and so on. I'll put this piece of the lesson in the Etherpad as well. I'll put it in line 146. And other shortcuts. Okay, it's something to remember that you don't necessarily always have to type everything out. So I'll put it in 146. You'll see it's there. It's a little note within the lesson itself. Okay, Stuart, thanks. Pierre, there is some documentation on animating with matplotlib. There's a link in the chat that Stuart just shared with us. Thank you very much, Stuart. Okay, so the next part of today is just...
Sorry?
Yes.
I wanted to ask, what did you do in order to make the figures to appear as a PNG file on the next tab?
Okay, when you look at my line 51, right, the code,
yes,
at the the bottom part, just above the graphs, you will see that there is a matplotlib.pyplot.save fig with a name. I'm highlighting it as we are. So then it will save it automatically in your current working directory.
Okay.
Okay, so meaning that when you go back to where we are currently working, which is within our data folder, the inflammation.png should be at the bottom of your inflammation.csvs.
I see it. Thank you.
Okay, no problem. Okay, so I'm done talking, hopefully, for today. The next part we're going to do is just some exercises yet again. So it's plot scaling, drawing straight lines, make your own plot, and moving plots around a bit. I think this question will ask you to, instead of having it in one row, have it in one column. So I'm going to paste this in the Etherpad as well. And then you can play around with it a little bit, and then we're done for the day. So let me just see what the first one is called. Plot scaling. Okay, cool. Okay, so when you look at line 151 of the Etherpad, that's the last exercise for today. The first question is, why do all our plots stop just short of the upper end of our graph? And if you want to change this, we can use the set.y limit minimum maximum method for each axis, for example, and it gives you an example of it. And then the question is actually, update your plotting code to automatically set a more appropriate scale. So it gives you a hint as well. Okay, so there's a solutions there, and then drawing straight lines is the next question. And the drawing straight lines question says, in the center and right subplots above, we expect all lines that look like step functions because non-integer values are not realistic for the minimum maximum values. However, you can see that the lines are not always vertical or horizontal. And in particular, the step function in the subplot on the right looks slanted. Why is this? So that's sort of an insight question. You can look it up a little bit, but I'll give you the answers as well. And then create a plot showing the standard deviation. So they're asking you to create a standard deviation plot. It is under make your own plot. Okay, cool. Plot. And then I think the last one is moving plots around. So the last one will ask you to put the plots all in the same column and not in the same row. Okay, so a quick question. Would you guys like to end for today? Or would you like to have some time to do this and then we discuss it before we end for the day? Or would you like to just do this on your own time this afternoon and then we can discuss it tomorrow morning for about 5 minutes before we start with the day's lesson?
I think we can discuss tomorrow morning before we start with the base lesson.
Okay, I think let's have a poll where you, I'm going to stop my share quickly. Okay, so in your Zoom, you will see that there is a reaction. So if you would like to discuss this tomorrow, please raise your hand so I can see who would like to discuss it tomorrow. By show of hands. If nobody shows their hand, then I'm going to give you a few minutes to do this and then we're going to discuss it today. Okay, it's just sort of a 50-50 split at the moment. So, okay, let's do this. Sorry. Let's be done for the day, because I know for most of you it's been a long day. It's a lot of information to take in a very short while. So let's end it for today, and then tomorrow, after we introduced ourselves to René's CEO, and before we start with tomorrow's lessons, we discuss it for a few minutes. If there's any hiccups, if there's no hiccups, we don't even have to discuss it. If everybody's happy with the way it was done, and then I'll give you the link to the lesson with all the, but you should be able to access the lesson as well, with all the answers in it, and then I'll give over to Stuart to do tomorrow's lesson then. But I will also be his helper, like he was my helper today. Okay, so that's it for today. Thank you all for your time and the effort that you've put in for the interaction. Then we will see you all tomorrow at 8:30.
Thank you. Before you go, thank you very much, Martin, for giving us the knowledge, for sharing with us the knowledge. We really appreciate you, sir, for that. Thank you. See you tomorrow morning. Cheers.
It's my pleasure. René, do you want to say something else?
I just want to thank all of you, exactly what Kweta said now. Thank you so much for thanking our instructors. I really appreciate that, because we all know that these guys are volunteers. So this is really precious that they're spending their time and imparting their knowledge. And also to all of you for attending, your time and knowledge. So I really hope that this is the beginning of a path, that we will all be working together for you all to become super users. Then all of you can become again instructors, and all of you can train other people, and they can, so it goes like a pebble in a pond. So let this be the beginning of something beautiful. Is there anybody else that wants to add something, or can we say bye? Okay, thanks guys. Lovely seeing you all. Then we meet tomorrow morning. Thank you once again for everybody. Okay, stay safe. We chat tomorrow.
Thank you.
Thank you all.
Thank you, everybody. Keep well. Take care.